Now, a quiz problem, this one. If a rigid body is rotating with a constant angular velocity about a fixed axis, the velocity vector at point P should be which one? And here, A, B, C, D. For answers A, B, C, they are all vector equations. C is not correct. dRp dt gives us velocity, angular velocity. How about A and B? And here, the correct answer should be A. Omega cross product Rp. This is vector calculation. Cross product omega cross product Rp is not equal to Rp cross product omega. Be careful here. Okay, next, a concept quiz problem. And here, a disk is rotating at 4 radians per second. If it is subjected to a constant angular acceleration of 2 radians per second square, determine the acceleration at point B. All answers are in vector form. So how to solve this problem? Okay, now the solution. This is an easy problem, but even for this easy problem, we still can follow the procedure. So firstly, we define this problem, and in this problem, a disk is rotating about its fixed axis. After defining the problem, now we can have a diagram. For this easy problem, for the disk, we can use the diagram in the problem, but we need define a coordinate system. And here, I defined a conventional X, Y, Z coordinate system. And here, I define positive rotation direction is counterclockwise. If the positive rotation direction is counterclockwise, then using right hand rule, the positive direction of Z will be outward. And here, of course, you can define your positive rotation direction clockwise. But if you define your positive rotation direction is clockwise, then using right hand rule, the positive direction of Z must be inward instead of outward. I, J, K are 3 unit vectors along X, Y, Z respectively. In this problem, we already know omega is 4 radians per second. We can express omega in vector form, but here we don't know its direction. In this problem, it doesn't indicate the rotation direction. This is not a problem when we solve the problem, because in the following calculation you will see the direction of omega is not useful. Angular acceleration alpha is 2 radians per second squared. This is already known. It's clockwise. According to this defined coordinate system, it should be negative. So in a vector form, vector alpha is equal to negative 2k radians per second squared. The radius of this disk is 2 meters. Okay, the target here is AB, the acceleration of point B on this disk. The equation we can use is AB is equal to vector ABT at vector ABN. So we need to work out these two components, then we can work out vector AB. ABT, vector ABT is equal to vector alpha cross product vector RBO. That will be negative 2k cross product negative 2j. RBO. RBO is direction is from O to B according to the defined coordinate system. This is downward negative. Okay, vector calculation, cross product. And we will get 4 vector k cross product vector j. Using right-hand rule, vector k cross product vector j, we can get a vector along x direction, so it should be I. And its direction can be determined using right-hand rule. It should be to left side, so the result vector is negative I. Okay, now ABT is negative 4I meter per second square. ABN is equal to negative omega square RBO, vector RBO. And here, omega square is a scalar. It's not a vector. And we already know omega is 4. RBO, again, negative 2j. So finally, we can get 32j meter per second square. So in a vector form, vector AB is equal to negative 4I at 32j meter per second square. Okay, C is the correct answer.